Welcome. I'm going to pick a few of these. This is 1.6, quadratic functions. They want us to say, is it a relation, just a relation, or a function? Everything can be a relation, but a function is very specific. A function, if you remember, it means that if you have a graph, let's say this is my graph, and you drew a vertical line, it would only intersect that graph in a single point. Okay, so for example, if you think about a circle is not actually a function because it intersects in 2 points. And we'll learn circle equations later on in the year. They also wanted a couple other things: type of growth, representation. We can do all of that. All right, why don't we start with this one? This one is a exponential. Okay, the reason I know that is because here there's a drop of 1, 2, 3, 4. Here there's a drop of 2. Here there's a drop of 1, and the next one is a half, and so on. So each time the growth factor is a half. Okay, so you're multiplying by a half. That has to be an exponential. The starting point, I can write the equation from this. The starting point is actually 1. So f of x is equal to 1. And the pattern is a half. And it's to the x power. All right. The change is multiplying by a half each time. So it's clearly an exponential pattern that we have here. And yes, it's a function. You've got that vertical line test and others. Let's look at number 5. First thing, is it a function? And right away, it's not a function. Okay, we can see that for one x value, there are 2 y values. So this is not a function. Okay, it's actually a parabola on its side, and in Module 8, we'll learn how to write the equation for this, but it is not a function. And there's another one I liked. The good old triangular numbers here. You can see why they're called triangles, triangular numbers here. It's also the sum of sequences: 1, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. The change, you're probably realizing, oh, look at the change. Plus 2, plus 3, plus 4. That change is a linear relationship. So therefore, this must be a quadratic relationship. And a equation for this is n times n plus 1 divided by 2. So f of n is equal to that. And then this one I like, the bloodstream. The rate is about 15% per hour. So let's say t equals time, and b equals the amount of caffeine in your blood. Okay, this is an exponential relationship because we have a growth factor of 0.15. It starts out at 500, so we could say b of t is equal to 500, and we're going to multiply that by 85%, 0.85, because each time it loses 100, and that's to the t. The t represents the number of hours here. Okay, so that's an exponential, and it's a function, also a function. This one is worth looking at. Notice that 4x plus 3 is linear. X minus 6 is linear. And if you multiply a linear times a linear, for example, x times x, you get x squared, so therefore you get a quadratic relationship. Okay, the change is you can represent with a linear representation. It's a quadratic relationship. Yep. All right, anything else? Yeah, this one's good too. So I like this graphical. This one you can see there's a parabola shape. So it has a parabolic shape. Therefore, it is a quadratic. I like this because you can see the symmetry. Here's my line of symmetry. So you can see that for each one of our x values or xy points here, there is another one on the opposite side that has the same height. The only exception is here, which is called the vertex, the minimum or maximum point. Every other point is part of a pair. And that